What's going on, my good people? How are you doing? It's 9 days since I last said I'll start recording on Spring AI, but the good thing is I'm here now. And I was moving to a new place. I'm really excited. Yes, yes, yes. I should possibly do a house tour, no? But that's it. So I said I'll be learning Spring AI, and just like I've done it before, but now I want to explore it kind of in depth. And as I try explore it, as I read the documentation and whatnot, decided to just like record so that people get to see how I learn and do things, and at the same time they get to learn from it as well. So I'll just get straight into it. So let me just reduce this guy here, and yeah. So for a very long time, I'd say, being a Java developer and thinking about implementing AI, sort of like since when AI came into the picture, it was a bit of a challenge. So you had to either pivot to Python, try have some Python in you, and if you're a person who is not like into Python like myself, would be discouraged when you want to integrate this in your applications. So there is LangChain, and then there was a branch for LangChain, which was LangChain for J, which was supporting Java. But now we have something that is it feels, for me, it feels closer to home, and home is Java. So with Spring and Spring Boot, you could easily have AI applications with the framework or the project called Spring AI. So what it does is the goal or the aim really is to help us integrate AI into our applications without unnecessary complexity in it. And then the documentation says that it draws inspiration from notable projects, Python projects such as LangChain. You definitely have heard about LangChain, and this is kind of the first time I'm hearing about Llama Index, so it also like helps us do this. But something to note very keenly is that Spring AI is not a direct part of this project, so it's something that is on its own. And then the project was founded with the belief that the next wave of Gen AI applications is not only for Python developers, but will be ubiquitous across many other programming languages, and that's the goal. So for Java, they are at the forefront of ensuring that as Java developers, you have access to all these tools so that you could be able to implement AI solutions in your applications without necessarily having the stress of thinking about Python and the rest of the languages. So like any other AI integration, we normally deal with fundamental things. You have your enterprise data, so all your data, and then you have the APIs with the AI model. So from this diagram here, we can see that just a sec. Yep. So you have your data, give it to the AI model, or just like anything you want. It could be a prompt, whatever, and then you get a response via your APIs that you have implemented to make calls to these specific like generative AI models. So Spring AI provides an abstraction that helps serve as the foundation for developing AI applications. And then these abstractions, they have multiple implementations. So this enables easy component swapping with minimal code changes. So here we're looking at the various abstractions that are provided. So yeah, there is a flexibility in how you interact with these models, and there is an abstraction for that, and then you could easily tweak your implementations to a specific one. You have Olama, you want to integrate with Olama, there's an abstraction that is provided for that. You want to deal with open AI models, you want to deal with cloud, name them. So Spring AI provides the following features. There's a portable API support across API providers for chat, text, and also embedding models. So if you're dealing with a chatbot, for example, for your company or for your application, there's a chat that is provided for that. So that's a portable API that is supported by Spring AI. There's a text to image, so you want to generate images from text, and then you also have embedding models when you're dealing with retrieval augmented generation, i.e. RAG. So both synchronous and streaming API options are supported. So yeah, you just choose your poison depending on the kind of application you're working with. So access to model specific features is also available. There is support for all major AI providers, very important, such as Anthropic, where we have Cloud, OpenAI, ChatGPT, and etc. We have Microsoft. So for Microsoft, there is what we call Azure Foundry. Azure Foundry is like a marketplace for AI models, and you could get like a bunch of them but there is that, and then there is Amazon, AWS Bedrock, so James Ward, and I hope I pronounced that right, and Josh Long have been doing a couple of workshops that just like specifically on Amazon. I've honestly not interacted with Amazon, but yeah, it's very possible for you to do that. There is Google as well. We have Gemini, we have Olama, Dashan's favorite. So whenever you want to try something locally without having to pay for API keys and whatnot, Olama is a good friend because you can have it locally on your machine and do a couple of things with it. So the supported model types include, so like I said, we have chat completion. So ideally give it text and then it does something for you. So ask what's the weather in Toronto, for example, it gives you a response if it has like access to a weather API or real-time data. Embedding, so embedding, now this one's for, yeah, whenever you're dealing with you want to create embedding. So most of the times you'll interact this when you're doing RAG implementations. Yep. And then you also have text to image, audio transcription. I've used this with Azure Foundry back then. It was so nice. Text to speech, and then you also have moderation, which this I have to look into and get to understand what it does. So yeah, okay, so that's a very nice thing. So if I click on moderation, open a new tab, it just takes me to this page. So that's something they need to fix, possibly. Yeah, there's also structured output. So you understand that later on we look at the kind of responses that the models give you. Most of the times it's just like string responses if you're dealing with chat completion and whatnot. So Spring AI has support for structured output. So there's somewhat what we call those two entity whenever you're getting your responses, and you could map the response instead of hard coding in your prompts. You could map the response to a specific entity. So you want your response in form of a JSON, and then this JSON would represent a specific entity like a student or a specific thing with a variety of fields. So it would map them into those entities. So maps AI model output to Pojo's plain Java objects. So there is support for all major vector database providers such as Apache Cassandra. I've not done this. Possibly we might try. What could possibly go wrong? All these: MariaDB, Azure Vector Search, OpenSearch, PostgreSQL, pgvector, Pine, Quadrant, Redis, Vector Store. Dashan loves that. And there's a portable API across vector store providers, including the novel SQLite metadata filter API. There is also an interesting thing called tool or function calling. So it permits the model to request the execution of client-side tools and functions, thereby accessing the necessary real-time as required and taking action. So this is what I said. You could ask your model the current time. So if it doesn't have access to functionalities that could help it track the current time, for instance, yeah, that would not be possible. But now there is what we call tools and function calling. So you expose it to a bunch of tools outside, like it has access to the weather API, or it has access to yeah, just some external sources like Google to perform some searches on Google and whatnot. So these are things that you expose there to the model as tools. So because it doesn't have like the real-time info about that, and then from there it could deduce depending on the kind of questions that you ask, and then it knows what to call. So if you ask for weather, it will look for a tool that provides the current weather. If you ask for who spoke at Java 1, it has a tool that has an access to the data of the things that happened in Java 1 and the kind of things that happened there. So yeah, that is that. And then there is one when somebody talks about observability, Thomas Vitale is the person who comes to mind. So he's sort of like a champion for observability. So ideally observability is just like providing insights into AI related operations. So for this one, we really are looking into Spring AI builds upon the observability feature in the Spring ecosystem to provide AI insight related operations. So the Spring Boot actuator model, you have the actuator model there, and then it provides the metrics and tracing capabilities to the core components from the chat model, chat client, for example. So you get access to a bunch of logs on how things were happening, also how the prompt was generated, how the response was coming by, and all these things, I guess we'll do them together. Fantastic. The other interesting thing that's there is what we call the AI model evaluation. Okay, there's ETL framework, so extract, transform, and load So this one is very important for data engineering and when you're dealing with RAG implemented based applications. AI model evaluation, so they help us evaluate generated content and protect against hallucinated responses. So this is a bunch of ways you could help tune or tweak your responses and ensure that the responses that the model provides is not hallucinated things. There's an auto configuration for this one for AI models and vector stores. You just add a dependency for it and then it auto configures it. The chat client API are very important fluent API for communicating with AI chat models. So this chat client is very important, idiomatically similar to the web client or the REST client. So this is an interface that sits between your Spring application and the actual model where the calls are being made to perform a specific thing. The advisors API, very good. So it helps encapsulate recurring generative AI patterns and then also transforms data sent to and from the models and provides portability across various models and use cases. So long story short, advisors are just like act as middlemen between both sides. So you build your application, you provide a couple of advisors. So these advisors, you could have an advisor for storing data into the vector store. You could have advisors on ensuring that the content is from support specific languages, and then you could have advisors that sit between, okay, both they look like reverse and forward proxy. So they sit in between the two things, and then what they do is they transform the data sent to the LLM and the data from the LLM. So if your LLM generates a bunch of it gives the answer, but it has a bunch of useless information attached to it, you could have an advisor that ensures that you only give the answer that is required. So Thomas has talked about this nicely. And then support for chat conversation memory and RAG as well. So you're able to store your chats. So it's once a user like Ian comes into your application, it won't forget that Ian said this and that. So there's memory for that. So this feature set lets you implement common use cases such as QA over your documentation and chatting with your documentation. So the concept section provides a high level overview of Spring AI in action, and then the getting started section shows you how to create your first AI application. So possibly in the next video, what we'll be looking at is the AI concept, so that we get to understand the basic AI concepts that do exist and how to understand them, the kind of terminologies you need before you start working or implementing AI into applications. So thank you for watching up to this very point. If the video was useful, consider leaving a like, or you could turn the notification, subscribe, just like help me support or boost the channel. Thanks for watching up to this very point, and till next time, have a lovely day. Bye.